Good morning, one and all present here. I welcome you all for this wonderful day. Uh, we are going to learn computer networks from Professor Dr. Aravind Swaminathan sir. He is going to give you the support for preparing GATE regarding computer networks. I welcome you, sir.
Thank you, ma'am. Thank you, ma'am, for your warm words of welcome.
Thank you, sir.
So, shall I proceed, ma'am?
Yes, sir. Yes, sir. Sure.
So, hello, everybody. Very good morning to you all, students. It's a pleasure to meet you all once again this morning. So, today we'll be seeing about computer networks with respect to the GATE preparation. Okay. So, the agenda for today's morning session will be like this. So, God willing, I'll be taking this session on 7th of October, 8th of October, and 9th of October. For 3 days continuously, I'll be taking in the forenoon sessions. And I thank the Lord Almighty for giving me this opportunity. And also, I thank the management of Fan Saver Engineering College. And I also thank AICT Prarana scheme for providing this wonderful opportunity. The agenda for today's class will be like this. It is like a concept of layering, OSI and TCP/IP protocol stack, basics of packet circuit and virtual circuit switching, and also about data link layer, about framing, error detection, medium access control, Ethernet bridging, and also about routing protocols. Okay, so we will have a brush up of these sessions. We'll have a revision of these sessions, and then we will at the end of these sessions we will take up some gate questions. We will take up some gate questions, and we will try to solve it. Okay, so the agenda will be like this. Okay, so I know that some of you who are in the pre-final year, you're studying computer networks, and the students who are in the final year, you would have studied computer networks in your pre-final year. Okay, so the students who are studying in the pre-final year, you will have you will be currently fresh. You will have a fresh knowledge on computer networks, and the students who are in the final year, you would have studied computer networks, then you would have studied web technology, you would have studied network security. You will have a broader and a better perspective. Okay. Anyway, we will have this session as an interactive session. I want to have this session as a interactive session, and we can have some questions, and you can interact whenever I'm asking the questions, and so that we get a better understanding of computer networks, and we are able to prepare for the GATE. Okay, so this as we all know, this GATE is a very prestigious examination, and I'm so glad that you are preparing for it. Okay, and wishing you all the best, and we'll get into the session. Yeah, let me first share my slide. Yeah, so we call it as the data communications. We call it as the data communications. So data communications, they are the exchange of data between two devices via some form of transmission medium, such as a wire or cable. So when you say computer networks, we all know that when we say computer networks, we need a sender, we need a receiver, we need a message, we need a protocol, uh, and also we need finally we need a medium. Okay, so this is the basic. Okay, so we need a sender, we need a receiver, we need a message, and also we need a protocol. Okay, so based on this five components only, the computer networks or the data communication takes place. Okay, so obviously the sender or the receiver can be any networking device. It can be any networking device. It can be a computer, it can be an iPad, or it can be a mobile, or it can be a server, or it can be any computing device. Okay, so we have the sender and we have the receiver, and we have the mediums. Okay, mediums. When you say medium, we have the two types of medium. How do we call the two types of medium? Any idea? How do we call the two types of medium? Medium. How do we call the two types of medium? Very good. We have the wired and also the wireless. What's the other name for wired and wireless? What's the other name for wired and wireless? I hope you wouldn't have forgotten. What's the other name for? Very good, very good, very good. We have the guided transmission media and we have the unguided transmission media. Okay. So this is also another important aspect. This is also another important aspect where we have the simplex, we have the half duplex, and also we have the full duplex. Okay. So simplex is like what it takes place in one direction, and we have the half duplex. It takes place in both the direction, but at one point of time, the data transfer takes place in only one direction. Okay. Also, we have the full duplex. We have the full duplex where the data transfer takes place it takes place in both the direction, and it can be at the same time at the both the direction the data transfer can take place. Okay. So when you say network, we call it as links or medium through which the nodes are getting connected, through which they are connected, which we call it as what? Which we call it as guided transmission media, or we call it as unguided transmission media. So the link can be a cable, it can be a air, or it can be optical fiber, okay, or it can be copper, it can be a coaxial cable, or it can be a copper wire. Okay, so these are the different kinds of medium which are used. So we'll see about what are the network criteria. Network criteria, we need the criteria of a network is measured by these three main aspects. One is called as the performance, which depends upon the network elements. So it is measured in terms of the delay and throughput. It is measured in terms of the delay and throughput. Okay. So when you say performance of the network, what comes into your mind? Any idea? You say performance of a network, what comes into your mind? Is there any other word? Very good, very good, very good. Superb, superb. That's great. Obviously. So we call it as the quality of service. The quality of service. So the quality of service, the delay has to be less, and the bandwidth has to be high. Bandwidth is the speed, okay, and the throughput also has to be high. And also, in addition to that, we can add that what the reliability has to be more. The reliability has to be more. So these are the aspects of the network criteria. So which can be called as performance. It can be called as performance, where it is called as it can be also called as the quality of service, where the delay has to be less, the throughput has to be high, and also the bandwidth has to be high. And of course, the reliability also should be more. The reliability also has to be more, where the failure rate of the network components has to be less. Okay, has to be less. And in this aspect, we have another term. It's called as fault tolerance. It's also called as fault tolerance. It's like though there is some fault that is taking place in the network, it still has to. It should still have the ability to work. It should have the ability to work. That is basically called as it is called as fault tolerance. Okay, which also comes under the aspect of the reliability. And obviously, these days, a lot of talk is being spoken on this aspect called security, on this aspect called the security, because today today it's like what data protection is very important, and the data has to be protected from errors, and also they have to be protected from malicious users. Okay, so yeah, the next point is regarding the types of connection. Next, it is regarding the types of connection. So we can have point to point and also multi-point, point to point and also multi-point. Or and in other words, we call it as what it is the which is the connection of devices. It can also be called as unicast, multicast, and also broadcast. Broadcast. Okay. So unicast is what is unicast? What is unicast? What is unicast? Unicast. What is unicast? Unicast. Unicast is one to one. Okay. Multicast is one to many. Okay. And what is broadcast? One to all. One to all. Okay. Very good. Very good. Fine. So one of the example for broadcast is the what? It is a radio or television. Radio or television. This is an example for broadcast. Okay, fine. So you can see here point to point. You can see here point to point, and also we can see here multi-point. Okay, multi-point from one mainframe. It is connected to more than two stations. Okay, more than one station. It is getting connected. This is a multi-point. Okay. Yeah, fine. In the aspect of computer networks, and the another important term is the topology. It is the topology. So topology is we call it as the geographical arrangement of the nodes. It's called as a geographical arrangement of the nodes. So we have the mesh topology, we have star topology, we have the bus topology, and also the ring topologies. So you can also have questions. Now you can also have questions like which topology is the best. Okay, and you can have questions like this. Okay, so when you say here the mesh topology is like what? It is fully connected. It is fully connected with each other. Fully connected with each other. And even if one connection fails, it can still work. Okay. But the disadvantage is that the infrastructure will be more. Okay. The infrastructure cost or the cost will be more. So the infrastructure will be more in the mesh topology. Okay. And we will also have the star topology. We also have the star topology where at the center we have the hub. We have the hub. So here, if the hub fails, the whole network fails. If the hub fails, we have the whole network fails. Okay. And also we know that we have the first topology where we have a single link, and using a tap, the stations are getting connected. Okay, the stations are getting connected. So this is the bus topology. This is the bus topology. Also, we have the ring topology, and here we have in ring topology we have a device called repeater. Okay, we have a device called repeater. So the role of the repeater is to amplify the signal. The role of the repeater is to amplify the signal. Okay. So here we have this ring topology, okay, where we see that it is in the shape of a ring, and all the stations are connected. Okay. And also we can also have a topology called hybrid topology. We can also have a topology called hybrid topology, where it can be a mixture of a star and also bus. We see it's a mixture of star, and also we have uh, bus. Here in this picture you see a star backbone with three bus networks. And also we have the categories of networks. Okay, we know that we have the local area networks, and which is for short distances. It is designed to provide local interconnectivity. And also we have the wide area networks. We have the wide area networks, and we are having it is used for long distances, and it is for provide connectivity over the large areas. Okay, and also metropolitan area networks for providing connectivity over the area such as a city or a campus. And we can also have isolated lands. Okay, and we can also have switched WANs. We can also have switched WANs, and we are using different devices for in the aspect of networking. We use different devices. We use devices like, so far we have discussed devices like hubs. We have discussed devices like repeater. We have devices like modem. Okay, modem. So modem, when it comes to internet, we talk about modem. So when you go for modem, what's the purpose of modem? What's the purpose of modem? Any idea? What's the purpose of modem? Modem is the purpose for the purpose of anybody. Where do you go for modem? Yeah, modem we go for, very good, very good, for modulation and demodulation, and for what, the conversion of analog to digital, and for digital to analog we go for modems. So we have the we can have a switched WAN. We can have, you can use the hubs. We can use the routers. So for normally for this is a symbol for hub. For routers we use the symbol circle with X. Okay, and also we can have the switches. Okay, through which we can have a heterogeneous network. Heterogeneous network is like, it's a combination of WANs and LANs. So here in the picture we have four WANs and also two LANs. We are having four WANs and also two LANs. We are having. Okay, fine. So a small introduction about the internet. Okay, the internet has revolutionized many aspects of our daily life. Okay, and also the business that is taking place. So we have for, when you say internet, it is the internet service provider. The internet service provider can be it can be the it can be a broadband, or it can be a Vodafone, it can be a BSNL, or it can be Vodafone, or it can be Airtel. Okay, like that. Okay. So next we have the protocols. Protocols is the set of rules, okay, and regulations through which the data transfer takes place. Okay. So we have the syntax, and we have the semantics, and also we have the timings for the protocols. Okay. So syntax is the structure or format of the data. Okay, and indicates how to, and semantics interprets the meaning of the bits, and timing is when the data should be sent and what. Okay, fine. Okay, fine. With this in small introduction, we'll straight go ahead into the layering. We'll see discuss about the layering part. So, are you able to see this slide? Layer task.
Yes, sir.
So in layer task, we see about we'll just see about the different layers, and also we'll see about what are the different roles of the layers, and followed by this we'll also see about some of the few questions like how they asked regarding in related to layering. Okay, so we are having the sender and also we are having the receiver, and we go for layering. We go for layering. So layering, the main purpose for which we go for layering is for what? For mainly for understanding the how the data transfer takes place, and to reduce the complexity. To reduce the complexity, we just go for this layering structure. And we know that the OSI model, it was established in 1947, the International Standard Organization, and it is like what? It was first introduced in the late 1970s, and we have the layered structure, and we'll see about how the layered architecture takes place, and we'll see about the difference between the ISO OSI and also about the TCP/IP protocol suite, and how the peer-to-peer process takes place, and also we'll discuss about the encapsulation. So ISO is the organization. Okay, ISO is the organization, and OSI is the model. Okay. So we have the 7 layers of the OSI model. We have the physical layer, the data link layer, the network layer, transport layer, session layer, presentation, and application. So with respective to gate, here they can mainly ask regarding they can mainly ask regarding here regarding the what are the main functionalities of the layers. With respective to the functionalities of the layer, the questions can be asked. The questions can be asked. Okay. So we have to clearly know. We have to clearly know about the functionalities of the different layers, and there can be some tricky questions. There can be some tricky questions with respectives or to the functionalities of the layers. So we can see here the lowermost layer is a physical layer, and next we have the data link layer. Next we have the network. We have the transport session layer, presentation layer, and the application layer. Okay, and they are connected by the routers. The routers, because the routers are the important devices. The routers are the important devices through which we are connecting the whole network is getting, or the world is getting connected only through the uh, router, which is the routing device. And we see here that we are having the lowermost layer. Okay, and it is like we see that in the physical layer, the data are in the form of, any idea how are the data in the physical layer? We all know that what the physical layer, the data are in the form of bits, zeros and ones. Okay, so there can be questions with respect to this. Okay, how that regarding the bits. There can also be questions. There can also be questions like we'll discuss about that regarding there can be match the following with respective to the layers and also to the functionalities of the layers and also to the functionalities of the layer. We'll see about that. So we have zeros and ones, and we know that in the data link layer, the data are called as frames, and in the network layer we call it as packets. Okay, and in the next we have the transport layer that we have in the form of segments. Okay, then we have the session layer, we have the presentation layer. Session layer is related to the timing and synchronization, and presentation layer is related to the encryption. Okay, and application layer is which the our application sits. Okay, our application sits. So we'll see. We'll discuss about the functionalities of these layers. We'll discuss about the functionalities of these layers. Okay, the different layer: the physical layer, the data link layer, the network layer, transport session layer, presentation, and application layer. We'll discuss about these functionalities. Okay. So we see that in the physical layer, the data are transferred in the form of zeros and ones. The data are transferred in the form of zeros and ones. And we are having the above the physical layer we have the data link layer, and also physical layer is responsible for what? Any idea? physical layer is responsible for what? Can you please respond to me? Physical layer is responsible for physical layer is responsible for. Can you please respond to me? Physical layer is responsible for. The physical layer is responsible for very good moments of individual bits, and also not only for bits, it's also responsible for the electrical and mechanical specifications. It's also responsible for electrical and mechanical specification. It means the all the physical components. It means the medium. The medium. It is like it can be coaxial cable or it can be fiber optics. Okay, it can be optics, or it can be twisted pair. Okay, there can be different kinds of cables. So the physical layer, it's not only responsible for the zeros and ones of bits that are being sent. It's not only related to the bit synchronization. It's not only related to the zeros and ones, but it is also responsible for the physical medium through which the data transfer takes place. So it can be optical fiber, it can be coaxial cable, or it can be copper wire. Not only that, it is also responsible the for what for the wireless communication that is taking place. Okay, fine. So there can be there can be questions related to the functionalities. So we have to be thorough with the functionalities of this layer. So the physical layer is responsible for movements of the individual bits from one hop to the next. Okay. And next to the physical layer, we have the data link layer. Okay. So in the data link layer, we are having the frames. Okay. The frames are we in the data link layer we call we the data flow in the name of frame. Okay, we call the data as frame in the data link layer. Okay, so below the data link layer we have the physical layer, and above the data link layer we have the network layer. Okay, so the data link layer is responsible for moving the frames from one hop to the next. It is responsible for moving the one hop to the is for moving the frames from one hop to the next. So you have to be very thorough with all the functionalities of the layers. So there can be questions regarding the functionalities of the layer. Okay. So at the end of this layering, we'll see about the few questions how they have asked regarding the how they have asked regarding the regarding the regarding the regarding the functionalities of the layer. So here the hop to hop delivery. So hop to hop. What do you mean by hop? Is like what from the data transfer that is taking place from one computer to one node to another router, another router to another router. Okay, and from another router to another computer. So this basically called as hop. This basically called as or this basically called as the hop to hop delivery. So when you take the network layer, uh, it is like we are having the on top of the network layer we have the transport layer, and below the network layer we have the data link layer. And obviously we know that the main functionality of the network layer is, yeah, can you complete it? Main functionality of the network layer. Main functionality of the network layer. The main functionality of the network layer is nothing else but it is the routing. Okay, routing is the main functionality of the network layer. So the network layer is responsible for the delivery of individual packets from the source host to the destination host. So we are having it can be the hop to hop delivery. Okay, so this is called as the hop to hop delivery, and this is called as the source to destination delivery. Okay. Next, we are having the transport layer. Okay, about the transport layer. So when you say transport layer, we are having we'll be seeing about the transport layer in detail in the next class. There we have the protocols like TCP, UDP, and also about the ACTP. About the ACTP. So the transport layer is responsible for the delivery of a message from one process to another. Okay, so the process-to-process communication takes place in the transport layer. This is very important, and this can be asked. This will be asked. So in the transport layer, the data transfer takes place as a process-to-process communication. And also we see that the network layer, we have the host-to-host delivery. Host-to-host delivery takes place in the network layer, and we are having in the transport layer, we have the process-to-process delivery. And the session layer is responsible for the purpose of synchronization. For the purpose of synchronization, we go for the session layer. And the session layer is responsible for dialog control and synchronization. And we are having the application layer. Okay, it is the topmost layer. Below the application layer, we have the presentation layer. Presentation layer is responsible for encryption. Okay, it's responsible for encryption. Is responsible for compression, and also it is responsible for the translation. All the translation, compression, and encryption takes place in the presentation layer. Encryption, compression, and translation takes place in the presentation layer. And finally, at the application layer, we have the different the human or the human user or the program. It sits on the top of the application layer. Okay, and we have different protocols working on the application like FTP, HTTP, FTP, and also we have the DNS, and also we have Telnet, and all these protocols, they're sitting on the application layer. So the application layer is responsible for providing the services to the user. Okay. So this is a very important. This is a very important slide which we have to see with respect to the gate. Okay. So we have here the physical layer. It transfers bits over medium. It provides the mechanical and electrical specification. As it told, the electrical and mechanical specifications are dealt by the physical layer. So in data link layer, for the organizing the bits into frames, and also to provide hop-to-hop delivery, we go for the data link layer. The data link layer, the data is called as the frames. Network layer, we call as packets for moving from source to the destination, and also to provide internet networking. And also we have the transport layer. We have the TCP, UDP, and SCTP. Here it is the process-to-process message delivery. And also we have the session layer for establishing and managing and terminating the sessions. And presentation layer, as we discussed, for the purpose of encryption, translation, and compression of data, we go for the presentation layer. And application layer is to allow access to the network resources. Okay. So also we have the TCP/IP protocol suite. Okay, so TCP/IP protocol suite, we have the 5 layers. We don't have the session layer and presentation layer in the TCP/IP protocol suite. Okay, so we can see here better the TCP/IP and the OSI model. We have the physical layer and the data link layer. The protocols defined by the underlying networks. Then we have the IP, and IP, it is working in the network layer. And along with the IP, we have the ICMP, we have the IGMP, and we have the ARP, and also we have the RARP. Okay, we have the RARP. So in the gate, we can also have questions related to ARP. We can also have questions related to ARP. So in ARP, it's like what we give the IP address, and we get the MAC address. So which one is given and which one is received? Okay, so this kind of questions can be asked in the gate. Okay, we'll see about that. And next we have the transport layer. We have the UDP protocol, we have the TCP protocol, and also we have the SCTP protocol. And also we have the in the TCP/IP. We are having the application layer. We don't have session layer separately, presentation layer separately, and application layer. TCP/IP protocol suite, we have the application layer as a we have it as a common one. We have it as a common one. So the layers are reduced to 5. Okay, we don't have the sessional layer and presentation layer separately. We have an application layer together in TCP/IP protocol suite, and we have the protocols like SMTP, FTP. We have the HTTP, DNS. Okay, we have the SNMP and also the Telnet. Okay, Telnet. Okay, so this basically it is called as what? These are the protocols that is working. So SMTP we know it stands for Simple Mail Transfer Protocol. FTP stands for File Transfer Protocol, and we have the HTTP. HTTP stands for Hypertext Transfer Protocol. We have the domain name service. That's a DNS. Then we are using the we have the SNMP. Anybody? Any idea what do you mean by SNMP? SNMP stands for anybody? SNMP. SNMP stands for SNMP stands for SNMP. Yeah, Simple Network Management Protocol. Okay, fine. Okay. Telnet. Why do you go for Telnet? Why do you go for Telnet? What's the purpose of Telnet? What's the purpose of Telnet? What's the purpose of Telnet? Telnet is very simple. I think pre-final. No, it's like provide bidirection. No, it's not for providing bidirection. It's not remote control also. Halfway you're right, Hemablassi. But Telnet is for anybody else. Can you please try it? Telnet. Telnet is for the purpose of local network. No. Telnet is for the purpose of remote login. Remote login. If you want to log in remotely to a machine, the machine is somewhere else. The machine is somewhere else. You want to log in. You want to log into that machine remotely. For example, we have a system at our college, and if I want to log in to that system from my home, then I can go for the remote login. Okay, remote login. That's basically called as telnet. Fine. Okay, fine. So yeah, in this connection also we have the different kinds of addressing. So this addressing is also very important. Okay. So we have physical address, we have logical address, we have port address, and also we have specific address. Yeah. Anybody can you just tell me what do you mean by physical address? 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 It's not very complicated. Yeah. Okay. You say yes type. Okay. Fine. Yeah. Physical address is nothing else but the MAC address. It's called the MAC address. Fine. So we also have the logical address. Logical address is nothing else but the what's the logical address? The logical address is the IP address. Fine. Okay. So we know about the port address. Port address. The port address works in which layer? Ports are specific to which layer? Okay, it's specific to the transport layer. Okay, it's specific to the transport layer because it comes along with the TCP UDP. Fine, fine, fine. Also, we have the specific addresses. Okay, and we can also have questions regarding to the. We'll also have questions regarding to the MAC address, also IP address. Okay, so these are the physical addresses, logical addresses, port addresses, and also the specific addresses. Yeah, we can see here, like what we discussed, we are able to have a clear depiction. So we are having the physical address. So physical address is more specific to the data link layer. it's more specific to the data link layer, but it works both in a combination between the physical layer and also the data link layer. And we have the network layer, and we have the logical address, which is nothing else but the IP address, nothing else but the IP address. And uh, we have the transport layer. We have the TCP, UDP, and also the SCTP. SCTP is a new protocol. It's the stream control transmission protocol, and also we have the processes which are working in the application layer, which are working in the application layer. Okay. Yeah, can you just tell me some of the other protocols which are working in the network layer? Just discuss right now, some 5 minutes back. Can you just tell me some of the protocols that are working in the network layer apart from IP? Can you tell me some of the protocols that are working in the that are working in the that are working in the network layer apart from IP? Any other protocols? Yeah, very good. ICMP, IGMP, very good, wonderful, wonderful. So ICMP, IGMP, ARP, RARP, all these things they are working in the what? They are working in the network layer. And the difference between ARP and RARP can also be asked as a question. The difference between ARP and RARP also can be asked in the what in the gate questions. Okay, fine. Okay, fine. So we are having uh, we know that what the IP addresses are in the form of IP addresses are formed in the form of it is in the form of 32-bit. IP version 4 is in the form of 32-bit, and MAC address it is in the form of hexadecimal. It is in the form of hexadecimal. Okay. So we can see here the application layer, transport layer. So we can see here we have the in the application layer we call the data as data. Okay, and we have the transport layer. There is small a and j. So it is like what the ports are getting added in the transport layer, and the network layer. The network layer we are adding the network layer. What are we adding? The network layer, which is getting added. Very simple. It's getting added along with the data. I hope you are able to see this diagram called port addresses. So in the network layer, which one is getting added? So we see a small a comma j in the transport layer, which is the port numbers. Okay, we see some capital A, capital P. It is nothing else but the source IP address and the destination IP address. Source IP address and the destination IP address. And next we have the physical addresses. Okay, so physical address will change from hop to hop. Okay, but usually logical address remain the same. So we can have different port numbers. Okay, fine. Yeah. So before getting into the next topic, we'll just see some of the gate questions. We'll see some of the gate questions. I just collected a few gate questions. We'll see. Let us see it with respect to let's see it with respect to layering. Yeah, let me share the slide to you. Are you able to see this? Are you able to see the gate questions? Able to see it?
Yes, sir.
So let us see the first question. Yeah. So let me read out the question. I hope you are able to see the screen. The following pairs of OIC protocol layer slash sublayer and its functionality incorrect. The incorrect pair is okay. Network layer and routing, transport layer and end-to-end process communication, data link layer and bit synchronization, medium access control and sublayer and channel sharing. Yeah, can you just give an answer for this? So the question is, in the following pairs of OSI protocol layer slash sublayer and its functionality, the incorrect pair is. So they have asked this question in 2014. Okay, network layer and routing. Okay, so they are asking for the incorrect pair. So they have given many correct pairs. So we have to choose the incorrect pair. So network layer and routing, transport layer and end-to-end process communication, data link layer and bit synchronization, medium access control, control sublayer and channel sharing. Yeah, can you give the answer? Anybody? Okay, Gandhi has answered. Very good. C. Very good. Very good. So the it is like what? Network layer and routing. They are what? Network layer is related to routing. Okay. Next, we are having transport layer. Transport layer is for end-to-end process communication. Then medium access control, sublayer, and channel sharing. They are related. Okay, fine. So yeah, fine. Okay. So I wish to ask a question. Bit synchronization is related to which layer? Bit synchronization. Bit synchronization is related to which layer? Bit synchronization is related to session. Huh? Okay, fine. Um, Bit synchronization is yeah. Okay, fine. So there's a doubt whether it is related to session layer or physical layer, but it is related to physical layer. Bit synchronization. Bit itself it is what related to physical layer. Okay, fine. One more question I wish to ask. Then what's the role of data link layer? What's the role of data link layer? What's the role of data link layer? Let me share the functionalities of the layer once again. I'm sharing the functionality of that layer summary. Right? So we can see here. You can see here the summary of the layers. Okay. You can see here what the physical layer. It is related to bits over medium. Everything related to bits. It is what it is related to the physical layer and electrical and mechanical specification. So frames and hop-to-hop delivery. Okay, and network layer, it is from source to destination, provide internet networking, and transport layer is process to process. Process to process message delivery is related to the transport layer. And for establishing, managing, and terminating sessions, we go for the session layer. And for encrypting, and for translating and compressing, we go for presentation layer. And it is what the application layer or the main layers that are sitting. Okay. So the bit synchronization is related to the physical layer. Okay. Yeah. Let us see a few more questions. And let me share the gate questions. So you can see here. Are you able to see the gate questions? Are you able to see the gate questions?
Yes, sir.
So you can see the explanation also. The data link layer has error control, flow control, access control, and framing as functionalities. But bit synchronization is a part of physical layer. Bit synchronization is a part of physical layer. So everything related to okay. Fine. So next we'll see the next question. Okay, fine. So here, as I told, this is also related to the functionalities of the layer. So they are given group 1 and group 2. So we have in P they are given as data link layer, Q they are given as network layer, R they are given as transport layer. So it is like what ensuring reliable transport data over a physical point-to-point link, encodes and decodes data for a physical transmission, allows end-to-end communication between two processes, and routes data from one network node to the next. Okay. So I think how we can find the answer is like, for example, if it's like what the answer they're given the ABCD as the choice. Okay. So in this connection, uh, we know that network layer for sure that it takes care of routing. Okay, it takes care of routing. So Q4. Okay, we see here Q4. There are two answers related to Q4. Okay, so it can either be A or B. It can either be A or B. Okay, so okay, Shivani has typed as A. Okay, anybody else? Anybody else? So Shivani says that A. So it means that data link layer ensures reliable transport of data over a physical point-to-point link. Okay, and transport layer deals with allows end-to-end communication between two processes. Okay, And data, the other option is it encodes and it encodes decodes data for physical transmission. It encodes and decodes data for physical encodes and decodes data for physical transmission. Okay. Any other answer? Anybody has okay, Shivani has typed A, Emma Blissy has typed A, Mitra has typed A. Okay. Yeah, so the answer is A. Okay, the answer is A. So the explanation is what data link layer offers reliability on link to link basis, where the transport layers offers that communication NPS basis. Network layer is responsible for routing. So we know that the network layer is responsible for routing. So we can know that it is the answer is either between A or B. Okay. Then transport layer is process to process communication. Okay. So we can know that what it is like what R is what three process to process communication and so it is like what when you say data link layer, it ensures reliable transport of data over a physical point to point link. Okay, fine. So there's one more question. Yeah. So in an Ethernet local area network, which one of the following statement is true? A station stops to sense the channel once it starts transmitting a frame. Okay. And the purpose of jamming signal is to pad the frames that are smaller than the minimum frame size. A station continues to transmit the packet even after the collision is detected. So this is related to the data link layer. So this is related to the data link layer. So we have a CSMA CD, carrier sense multiple access collision division. Okay. So yeah, any idea? What's the answer? Any idea? Any idea which one is the answer? Yeah, Isai. Okay. So it is like exponential back off. Okay, exponential back off mechanism reduce the probability of collision or retransmission. So we know that what here they are using the exponential back off mechanism. Okay. So further questions we'll see about the data and we'll see about the data link layer, and then we'll come back to the gate questions. Okay, fine. Yeah, next we'll come to we'll see about the data link layer. So data link layer is also very important, and here we can have questions related to the MAC address, okay, the physical address, MAC address, okay. With this related, we can have questions. So now we'll see about the data link layer. Okay. So we know that the data link layer is further divided into two layers. How do we call the two sublayers of data link layer? How do we call the sublayers of the data link layer? Any idea? Now, how do we call the two sublayers of the data link layer? Yeah, so we call it as MAC. One is we call it as MAC, and also we call it as logical link control. Okay. In some books they are called as a logical link control. In some books it is called as data link control. Okay. LLC and MAC. Okay, LLC and MAC. Fine. So here, when you say about data link layer, we have it's what we come across the concept of the two sublayers. Okay, and we have the MAC sublayer and also logical link control comes into picture. When you say about MAC sublayer, also we have the MAC address also comes into the picture. The MAC address also comes into the picture. Okay. When the MAC address comes into the picture, also we have the ARP and also RARP. Okay. Though ARP and RARP are part of the network layer. So when we say ARP, okay. So like what? Which address we are giving and which address we are getting. Whether we are giving in ARP, whether we are giving the internet protocol IP address and we are getting the MAC address, or whether we are giving the MAC address and we are getting the IP address. Okay, so this kind of questions can be there. Okay, this kind of questions can be also there. Okay, they've asked. We'll see about that. Okay. So another important aspect which you have to understand is like what are the different devices that are working in the different layers. Okay, what are the different devices that are working? That can also be questions like this. What are so this it is a better understanding. So yeah. So which device works in the physical layer? Which device works in the physical layer? Which device works in the physical layer? Can you tell some of the devices that works in the physical layer? Bridges. Very good. Very good. The repeaters and the hubs. Okay, according to my knowledge, very good, Shivani. The repeaters and the hubs, they are working in the repeaters and the hubs. They are working in the physical layer. Bridges. Bridges. What's the purpose of bridges? What's the purpose of bridges? So there are also questions like the purpose of bridges. So normally for the purpose avoiding for why do we go for bridges? Connecting two networks. Yeah, it is for connecting more than saying connecting two networks, connecting the two LANs. For connecting two LANs, we can go for bridges. For connecting two LANs, we go for bridges. And also bridges are used to avoid loops. Bridges are also used to avoid loops. Yeah, fine. So okay. Uh, which device works in the data link layer? Which device works in the data link layer? Which device works in the data link layer? Which device works in the very good, very good, very good, fine, fine. Switch works in the data link layer. Fine, fine. Okay, okay. And which device works in the network layer? Which device works in the network layer? Superb, superb. Router works in the network layer. Fine, fine. Wonderful. So the switch works with which address? Switch works with which address? Switch works with which address? Physical address. Wonderful. Yeah. What's the other name for physical address? What's the other name for physical address? MAC address. The MAC address is in the format of what? Which format is the MAC address? Hexadecimal. Okay, hexadecimal. Okay, fine. So the routers, they are working in which layer? Routers works in which layer? Router works in which layer? Router works in the network layer. Very good. Okay. What address do we use for routing? What address do you use for routing? IP address. Okay. Fine. Okay. So both IP version 4 and IP version 6 can be used. What's the size of IP version 4? 32-bit. Okay. IP version 6. Okay, fine. Yeah, what's the advantage of IP version 6? What's the advantage of IP version 6? What's the advantage of IP version 6? So there is security, more security, and there's more flexibility. Fine. Okay, fine. So we can have communication at the data link layer. We can it can be like what we can have the switches can form the can help to form a switch band. Okay, and we can have we can have a network is formed in combination of a LAN switch and also a WAN switch and also routers. Okay, for example, in our lab, in our lab, in our individual lab, what device do we have? In our individual lab, what device do we have? For example, if you take lab 3, network lab, what device will we have? Will we have? What device will we have? That we'll have we'll have a common router for our college. We'll have one router for our college. For individual separate labs, we'll have individual switches. We'll have individual switches. That is how we are having the arrangement in our lab. Okay. So we are having this. We can see now. This is what I told. We can, for example, you take this router. It is our college. Okay, from our router, our router is placed in the what in the server room. From there, there's a LAN switch. There's a switch, and from that we have different systems that are getting connected. There are different systems that are getting connected. So in every switch, I'm sorry, in every lab there will be a separate switch through which all the systems are connected. Okay. Normally, for our college, we'll have a single router. Okay. Okay. So, this is a general question: which device will be costly? A switch will be costly, or a router will be costly? Router will be costly because there is a software that is running in a router. There is a software that is running in a router. What's the software that is running in a router? What's the software that is running in a router? What's the software that is running in a router? What's the software that is running in a router? Anybody? What's the software that is running? Firmware? No. What's the software that is running in the router? So we have a router. we have a software in a router. Okay, we have a software in a router. Why do we know? Why do we need a software in a router? Why do we need a software in a router? Why do we need a software in a router? Why do we need a software in a router? Very simple question. Nothing complicated. Why do we need a software in a router? Very simple. As simple as that. Perform routing. Obviously. So what is routing? What is routing? What is routing? Yeah, selecting the best path. Okay. So for selecting the best path, we go for routers. Okay, and this is basically called as routing. And to select the best path, we go for different algorithms and we go for uh, different routing techniques. Okay, so we have what dynamic source routing, we have link state routing, okay, OSPF, okay, open shortest path first. Okay, so we'll see about that in the coming sessions. Okay, fine. So obviously, since a software is running, so a router is also similar to a what? A router is similar to a what? Router is similar to a computer. A router is similar to a computer. Like how we in a laptop or in a computer there is a software running. Same like that, there is also a software that is running inside a router. The router that is running inside the router. I'm sorry, the software that is running inside a router. It is called as iOS. It is called as iOS, Internet Operating System. Okay, fine. So it is like what? So you need that there are a lot of algorithms that is running the software that is running the software. So there's also a lot of programming that is done related to routing. Okay, so we should not consider. You should not take that router is a hardware device, so everything is a hardware. It's not like that. We have our software, we have algorithms, and also there is also programming is also needed for doing the routing purpose, which is the selection of the best path. So we can have the diagrams, okay, and we can have the actual link, and we can have the logical link, in which the data are flowing. So we are having the two sublayers, MAC sublayer and also DLC, the data link control or logical link control. These are the two sublayers which are in the data link layer. So it's the MAC sublayer and data link control or logical link control. In normally we call it as LLC, logical link control. Some books they are called as data link control. So we have two sublayers in the data link layer. One is called as a MAC, media access control. Another one is the logical link control or the data link control. We can call it logical link control itself. Okay. So we can have link layer addressing, which is what nothing else but the it is nothing else but the physical address. So nothing else but the physical address or sometimes a MAC address. So so in the data link layer, we will have both the logical layer and also the physical layer. We'll have both the logical layer and also the physical layer. Logical layer is the IP address, and also we'll have the MAC address, which is the MAC address, which will be in the form of a hexadecimal. So also we already seen we have the unicast, multicast, and also the broadcast. So this is the hexadecimal format. This is the hexadecimal format for the in the hexadecimal format for the physical address, which is the MAC address. Okay. Okay. So can you find the MAC address? Can you find the MAC address of a machine? Can we find the MAC address of a machine? Yeah, how can you find the MAC address of a machine? How can you find the MAC address of a machine? How can you find the MAC address of a machine? How can you find the MAC address of a machine? How will you find the MAC address of a machine? Okay, fine. How will you find the IP address of a machine? IP config. Very good. Very good. Using typing IP config on the command prompt, we can find the IP address. How will you find the MAC address? Yeah, IP config space / all. If you type IP config space / all, you can find the MAC address of a machine. Okay. Normally, where is the MAC address? 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 Where is the MAC address normally? So MAC address is what? It is what? It is the MAC address is in the network interface card. It is bound on the network interface card. MAC address is bound on the network interface card. Yeah, let me repeat this one once again. So IP config is for finding the IP address of a machine. Okay. Type the IP address of machine. This is IP version 4 address. Okay, this is the default gateway. Default gateway is what? It is the this is the default gateway is the IP address of the router. IP default gateway is the IP address of the router. Okay, fine. So IP, you type IP config /all. Okay. So we can see the MAC address. You can see here physical address. You can see here physical address. So this is the IP address of the this is the MAC. This is the physical address, which is the MAC address. This is a hexadecimal form. It is burned in the network interface card. It is burned in the network interface card. Okay. So we have also known about ICMP. Okay. ICMP stands for what? ICMP stands for what? ICMP stands for ICMP stands for ICMP stands for come on, tell me. Internet Control Message Protocol. So the ping is a part of ICMP. For example, using ping. Okay. So I can the default gateway is the IP address of my router. Default gateway is the IP address of my router. I can just check whether I am connected to the my the router. So using the what? Using the ping command is used for checking the connectivity. So it says that what? Packet 4 packets and receive 4 packets. Okay. This is the round trip time in milliseconds. Okay. So next we have the ARP. Okay. So ARP is like what? We give the IP address and we get the MAC address. Okay. RARP is the reverse. We can see here ICMP. We have IGMP and IP. All these things they are working in the network layer. They are working in the network layer. So you give IP address and you get the MAC address. Okay. So this format of the ARP packet source address. We have two address. One is the IP address, and also we have the physical address or the MAC address, which is called as the hardware address. Okay. So with this understanding, let us see about some of the gate questions. Fine. Okay. I hope you are able to see the question. You are able to see the questions. Okay. The question is, in a network of LANs connected by bridges, so packets are sent from one LAN to another through intermediate bridges. Since more than one path may exist between two LANs, packets may have to be routed through multiple bridges. Why is the spanning tree algorithm used for bridge routing? What's the answer? I hope you are able to read the questions. A network of LANs connected by bridges, packets are sent from one LAN to another through intermediate bridges. Since more than one path may exist between two LANs, packets may have to be routed through multiple bridges. Why is the spanning tree algorithm used for bridge routing? What's the answer? I think we discussed uh, so for avoiding Berlin-Richmond has answered. So the answer is, for avoiding loops, we go for the spanning tree algorithm in bridges. For avoiding the loops, we go for spanning tree algorithm in the bridges. Okay, fine. So a bit stuffing based framing protocol uses an 8-bit delimiter. If the output bit after stuffing is 0 111100101, then the input bit string is, any idea? So normally, when we have 5 bits continuously, normally when we have 5 bits continuously, we go for what? We go for this. We just introduce one and zero. Okay, we use 1 and 0. So this is the bit stuffing concept. And selected reject, we'll see. We'll come back. We'll see about selected reject. So since we saw about address resolution protocol, you can take up this question. The address resolution protocol, ARP is used for. Can you give the answer for this one? Can you give the answer for this one? Regarding the address resolution protocol, we saw that what? The ARP, RARP, ICMP, and IGMP, it works in the network layer, and we saw that what ARP is related with the what with the MAC address and also the IP address, mapping of MAC address and the IP address. Okay. So with respect to this question, can you give the answer? The address resolution protocol ARP is used for ARP. The address resolution protocol ARP is used for finding the IP address in the DNS, finding the IP address of the default gateway, finding the IP address that corresponds to the MAC address, and finding the MAC address that corresponds to an IP address. Yeah, can you give the answer? Can you give the answer? The address resolution protocol is used for finding the IP address from the DNS, finding the IP address of the default gateway, finding the IP address that corresponds to a MAC address, and finding the MAC address that corresponds to an IP address. What's the answer? Are you able to see the question? Yeah. So the answer is D. So you find the MAC address that corresponds to an IP address. Okay, fine. So there can be also questions like regarding the this protocols related to the data link layer, the selective, and also regarding the go back end about the sequence number that is being used. We'll see about that now. Well, let me share the screen. So we'll see about some points regarding the framing and also related to stop and wait regarding the protocols. And also we'll see about the acknowledgement, negative acknowledgement, and also regarding the sequence numbers. Okay. So we see here that the data link layer needs to pack the bits into frames. So it is like then the data link layer, we are calling it as frames. So that each frame is distinguishable from another. So our postal system also the practices a type of framing. The simple art of inserting a letter into an envelope separates one piece of information from another. The envelope serves as the delimiter. Okay, so we can have fixed size framing and also we can have variable size framing. So we can have the flags. We can also have we can have headers. We can have the trailer and also we can have the flags. So they have asked questions related to byte stuffing and bit stuffing. We'll see about that. So byte stuffing is the process of adding one extra byte whenever there is a flag or escape character in the text. Okay, byte stuffing is the process of adding one extra byte whenever there is a flag or escape character in the text. Okay, so in byte stuffing, we add one extra byte when there is a flag or escape character in the text. So we know that what frame is a bit-oriented protocol. So bit stuffing is the process of adding one extra zero whenever five consecutive ones follow a zero in the data. We saw that there was a question asked regarding the bit stuffing. So you can please note down regarding bit stuffing. So bit stuffing is the process of adding one extra zero whenever five consecutive ones follow a zero in the data, so that the receiver does not mistake the pattern. Bit stuffing is the process of adding one extra zero whenever there are five consecutive ones. Whenever there are five consecutive ones, we will add a zero. We'll add a zero so that the receiver does not mistake for a pattern. Okay. So whenever there's a five consecutive one, we add a zero in the data. That is basically called as the bit stuffing. You can see here. So when there is five consecutive ones, you can see that data from the upper layer. So when there's a five consecutive ones coming, there's one zero that is being added. Okay, there is one zero that is being added. So this is basically, it is called as what? It is called as the concept of bit stuffing. So we can have questions related to this bit stuffing. And so the data link layer is related to the flow control and the error control. The data link layer is related to the flow control and error control. And collectively, these functions are known as the data link control. They are called as the data link control. So flow control refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for an acknowledgement. So it is like what, when the data are being sent and the receiver is not able to receive the data. Then the the receiver will get overwhelmed and it cannot be in a position to receive the data. So for that only we go for the concept of flow control. So this concept of flow control is implemented in two layers. Which are the two layers in which the flow control is getting implemented? Flow control is getting implemented in two layers. Which are the two layers in which the flow control is getting implemented? Any idea? Flow control is getting implemented in two layers. Flow control is getting implemented in two layers. Which are the two layers? There are two layers in which the flow control is getting implemented. So the flow control is getting implemented in two layers. One is the data link layer, and also it is getting implemented in the transport layer. Also implemented in the transport layer, data link layer, and also it is getting implemented in the transport layer. So flow control refers to a set of procedures used to restrict the amount of data that the sender can send before waiting for an acknowledgement. So we have error control. The data link layer is based on automatic repeat request, which is the retransmission of data. Okay. So if there is some error in the data that is being, we ask for automatic repeat request. We ask for automatic repeat request, or we ask for the retransmission of data. So this is done using the error control. So we can see we can have different protocols that are working in the data link layer. We can have different protocols that are working in the data link layer. So we'll see about the different protocols that are being implemented in the data link layer. So using this protocol in the data link layer, we are able to do the framing, we are able to do the flow control. Also, we are able to do the error control. We are also able to do the error control. So the protocols that are used in the data link layer are, we can have the simple protocol, and also we can have the stop and wait protocol. Simple protocol and the stop and wait protocol, they are used in a noiseless channel. Okay, and for a noisy channel, we go for stop and wait ARQ. We go for go back N ARQ, and also we go for the selective repeat ARQ. We go for the selective repeat ARQ. So we have in the noiseless channel, we have the simple protocol, and also we have the stop and wait protocol. We have the simple protocol and the stop and wait. So we have the sender and also we have the receiver. We have the sender and also we have the receiver, and the frames are being sent from the sender, and we have an algorithm at the sender side. Also, the receiver at the receiver side, we are receiving the data. So we can have a simple algorithm like this: while true, wait for even. You are getting the data. You can make frame and you can send the frame. So here in the simple protocol, we don't have any acknowledgement. We don't go for any acknowledgement in the simple protocol, which is a noiseless channel. The frames are being sent from the sender side to the receiver side, and at the receiver side, we are receiving the frames. So in the stop and wait protocol, we are having the sender, we are having the receiver, and we are having the acknowledgement. Okay, sender sends the data frame, and once the data frame reaches the receiver sends the acknowledgement frame. The receiver sends the acknowledgement frame back to the sender. So we can also have a algorithm like this. So you can see here, we have the sender sending the frame, the receiver is sending back a order. This protocol, simple protocol, and stop and wait are part of the noiseless channel. And for noisy channel, we go for the noisy channel. We go for stop and wait automatic repeat request. Also, we have the go back in automatic repeat request, and also we have the selective repeat automatic repeat request. So these are protocols are related to the noisy channels. So error correction in stop and wait ARQ is done by keeping a copy of the sent frame and retransmitting of the frame when the timer expires. So we keep we use the timer, and with the help of the timer, we are waiting whether the data is sent and whether the acknowledgement is received. So every operation is based on the timer. Every operation is based on the timer that is being used. So in stop and wait ARQ, we use sequence numbers to number the frames. The sequence numbers are based on modulo 2 arithmetic. So we see that stop and wait ARQ, we use the sequence numbers. Number the sequence numbers are based on modulo 2 arithmetic. So this sequence numbers only they have asked as a question. The sequence number only they have asked. So like what they have asked like what in stop and wait it is modulo 2 arithmetic. Okay, same like that we can have for selective repeat. There can be the arithmetic can be different. Okay. So we have to know what kind of arithmetic is being used for uh, everyone. Okay. For example, the question which they have asked is like for selective reject protocol. For selective reject protocol, what's the sequence number we are using? That it was 2 power n minus 1. It was 2 power n minus 1. Okay. So we should know what are the sequence numbers. So here we see that for in stop and wait ARQ, the sequence number is modulo 2 arithmetic. So here we are having the stop and wait ARQ protocol. So it is like what we are sending it, and also we are using we are getting the acknowledgement, and we are using the timers. This one, this algorithm for stop and wait ARQ. So sometimes the frame can be lost. Sometimes the acknowledgement can also be lost. So here go back end protocol. We can use the go back end protocol. So for go back end protocol, we are using the window. We are using the window, and we are using it. For that, the sequence numbers are based on modulo 2 power m. They are based on modulo 2 power m. And we can have the uh, first the first element of the window, the next element in the window, and also the size of the window. And we can have the sequence numbers also. This is a go back in ARQ. We have the sender, we have the receivers. So we can use the window size, and we can see here for go back in ARQ, the window must be less than 2 power m, and it has to be less than 2 power m. So we can see here that Okay, let's see the bit stuffing question once again. Yeah, let me share the gate question. So you can see here a bit stuffing question has been asked. A bit stuffing based framing protocol uses an 8-bit delimiter pattern 0 1 1 1 1 1 1 0. The output bit string after bit stuffing is uh, 0 1 1 1 0 0 1 0 1. Then the input bit string is they've asked. Okay, so here here you can see that the answer is like. So we see that after uh, when there is when there is consecutively when there is consecutively 5 ones, when there is consecutively 5 ones, the bit stuffing is taking place. You can see here that the bit stuffing is taking place. Yeah, we see that what uh, when there is when there is 5 ones, when there is 5 ones continuously, there is a zero that is getting inserted. There is a zero that is getting inserted. Next, let's see let's refresh regarding the network layer. Yeah, let's see about the network layer, about router and routing. Then we'll see about the gate questions. Yeah, let's quickly revise the network layer, and then next we'll go for the gate questions. So network layer, here we call the data as packets, and the routing takes place in the network layer, and we are using the network interface router here. So we are having the router denoted by this symbol, okay, and the host to host delivery takes place the network layer. So the forwarding means to place the packet in its route to the destination. Forwarding requests a host or a router to have a routing table. So we use the routing table in the for the purpose of routing. We use the routing table for the purpose of routing, and we can have the network, and the network we are connected to the network with the help of a router, and we establish the network, and we can have the host A, and we can have host B. So we can have our routing tables. So here we can have our source, we can have our destination, and the next hop to which router we are going to get connected. So for example, the routing table for host A, we can have the destination is N2. We are going through the router R1, and we can have our address. So it's like what we can use our ARP is also getting implemented, where we are giving our IP address and we are getting the MAC address, okay? And the data transfer takes place with the help of both the IP address and also the MAC address. So we can use the classless address, and also we can use the classful addressing. So a router can have its interfaces. A router can have its different interfaces. We see here M0, M1, M2. Okay, these are the different interfaces. So we can have our mask. We can have our the network can have its address, and also through the interface it is moving. For example, we can see here router table for R1. This for R1. We see that we can have different interfaces M0, M1, M2. So interfaces are nothing else but ports. They are nothing else but the ports through which the connection is getting established. So we see that M2 is getting we have a IP address called 180.170.65.192. Here we are having M0. So it is getting established to the network 180.170.65.1. Then we are having M1. We're having 201.4.16. This is how the connections are established using the different interfaces. So this for address aggregation. So we can have a router. It can have different interfaces like M0, M1, M2, and M3, and through which we can get connected to different organization. Okay. So 140.24.7.0 can be one organization. 140.24.7.64 can be another organization. 140.24.7.128 can be another organization. So this how the address aggregation can be there, and also it can have a routing table. So same thing, it is implemented. It is shown here. We can have the ISPs also, which we are getting the internet connectivity is received. So the common fields that can be in a routing table can be like this. It can be a mask. It can be the network address, next hop address, interface, uh, reference count, flags. So these can be the different fields that can be there in now that can be available in a routing table. Finally, there's a command called netstat. Netstat is a command in Unix. It can also be used in DOS. It can also be used DOS. So it is used for showing the status of the network. For showing the status of the network, we can use this netstat command. Yeah, let me show it, and next we'll go to the gate questions finally. So this is a command called net. So through this we can know the status of our network. I hope you are able to see the screen. So this is a netstat command through which we can know the status of our system, like what, how many connections are there. Okay, what are the protocols that are being used. Okay, and we can see here. We can see here our local address, the IP address. We can see the IP address and also the port number. Okay, and in which status it is. Okay, in which status it is. So this is the use of the netstat command. Same like that. There's another command called traceset also. So what is the path it is taking to reach a website? Is given using the command called traceset. You can see the how many hops it is taking. to get connected to a website. Use the use of this commands called netchat and tracer. Tracer is also part of ICMP, Internet Control Message Protocol. So it is taking 15 hops. To reach www.fancysaver.ac.in, it takes 8 hops. Here we see that it is taking 15 hops, 16 hops, 17 hops, and finally 18 hops. Okay. Fine. Finally, let's come to the gate questions. Yeah, there are a couple of questions related to bridge and router. We'll see that. Okay, fine. Are you able to see the screen? Are you able to see the question? Are you able to see the question? Yeah, you can please answer to this question. Thank you, Ganimali, for responding. So, which of the following is not true with respect to a transparent bridge and a router? What's the answer? What's the answer? Anybody? Can you respond? Shivani, can you take up the question? Emma Blessy. It's a very difficult question. It's not a very difficult question. Which of the following is not true with respect to a transparent bridge and a router? Gandhi has responded. Okay, fine. So a bridge uses an IP address, with the router uses a MAC address. Okay. So we have to be very careful because it is like we have to see whether it is true or not true. It is true or not true. Okay, because it is like whether the question is they have asked is whether which of the following is true or not true. Okay. So a bridge uses IP address where a router uses a MAC address. Okay. So it is like what? It is a false answer because a router always uses a what? A router always uses a IP address. A router always uses the IP address. A router does not use a MAC address. Okay. So, so the answer is a bridge uses a IP address while a router uses a MAC address. Okay, fine. Yeah, let's move to the next question. Which of the following assertions is false about the Internet protocol? Which of the following assertions is false about the Internet protocol? Which of the following assertions is false about the Internet protocol? It is possible for a computer to have multiple IP addresses. IP packets from the same source to the same destination can take different routes in the network. IP ensures that a packet is discarded if it is unable to reach the destination within a given number of hops. The packet source cannot see the route of an outgoing packets. The route is determined only by the routing tables in the routers on the way. Okay. Yeah. Have you answered? Anybody can you answer? Gandhimati, Shivani, Ratika. Is it a very difficult question? Which of the following assertions is false about the Internet protocol? It is possible for a computer to have multiple IP addresses. Why you are taking such a long time? What's the answer? No idea. Okay, Shivani has responded. Yeah, very good. Thank you for responding boldly. Okay. So here it is like the packet source cannot set the route of an outgoing packet. The route is determined only by the routing tables, the routers on the way. Packet source cannot set the route of an packet source cannot set the route of an going packets. The route is determined only by the routing tables in the routers on the way. Okay. So it is like what the routes are not determined by the routing tables on the way. No, it is like what previously itself. It is what it is. And the routes are set. Okay. So it is the false answer. And also it is like what computer can also have there is permissions that a computer can have multiple IP addresses. Okay, fine. Okay, so RIP we have not seen so far. Okay, but anyway we'll take it. Which one of the following is true about the interior gateway routing protocols? Routing information protocol and open shortest path first. RIP uses distance vector routing and OSPF uses link state routing. OSPF uses distance vector routing and RIP uses link state routing. Both RIP and OSPF uses link state routing. Both RIP and OSPF uses distance vector routing. Any idea? Anyway, tomorrow we'll see about routing. In routing, we'll see it in detail. Any idea? Which one of the following is true about Internet Gateway protocols? Routing RIP and open shortest path first. RIP uses distance vector routing, and OSPF uses link state routing. OSPF uses distance vector routing, and RIP uses link state routing. Any idea? Any idea? I think the first one is correct. RIP uses distance vector routing and OSPF uses link state routing. So it's RIP uses the distance vector routing and OSPF uses the link state routing. Follow? RIP uses distance vector routing and OSPF uses link state routing. RIP uses the distance vector routing and OSPF uses the link state routing. Okay. Okay, fine. Let us so we'll take up this question. Consider the following three statements about link state and distance vector routing protocols for a large network with higher 500 network nodes and 4,000 links. So there is a 500 network, 500 nodes are there and 4,000 links are there. Okay. Computational overhead in link state protocols is higher than distance vector protocols. Okay. Next, distance vector protocol avoids persistent routing loops, but not a link state protocol. After topology change, a link state protocol will converge faster than a distance vector protocol. Which one is correct regarding? Okay. So we see here where there are 500 nodes and 4,000 links are there. Okay. So we see that computational overhead in a link state protocol is higher than in distance vector protocols. Computational overhead in link state protocols is higher than distance vector protocols. Because the reason here is like the updation takes place more frequently in link state routing protocol. Updation of the updation about the nodes. Okay, the updation about the nodes and the updation about the costs, everything takes place more frequently in a link state protocol than in distance vector protocol. In distance vector protocol, the updation protocol is limited, but in link state protocol, the updation takes place in a very faster manner. So after topology change, link state protocol will converge faster than a distance vector. So after when the topology changes in the node, particularly in a wireless, okay, when it is moving, when the nodes are moving, it's like what it is like what the updation takes place in a faster manner. Okay. So distance vector routing protocol avoids persistent routing loops, but not a link state protocol. So link state routing protocol only avoid loops. So loops should be present or loops should not be present in routing. Loops should be present or loops should not be present. Loops should be present or loops should not be present. So having loops is an advantage or a disadvantage? Having loops is an advantage or a disadvantage? So obviously, having loops is a disadvantage. So having loop is a disadvantage. Okay, fine. Fine. So let us summarize the points which we have seen. Okay. let us summarize the questions which you have seen. Okay. That we will summarize the class. Okay. So we especially we saw about the layering. Okay. We'll summarize the class. So we saw about the layering. So the roles of each layer has to be studied very well. The roles of each layer has to be studied well. Okay. So the network layer related to routing. Okay. And transport layer related to end-to-end process communication. Presentation related to translation, encryption. Okay. Then uh, then the physical layer related to bit synchronization. Okay. So all these the roles of the layers has to be studied well. Okay. So students, when you prepare for this gate, please have a good idea on the roles of layers. So please do study about the roles of the layers. Okay. Roles of the layers, you please study well. Okay, fine. Next is like uh, we saw about this is also related to related to the data link layer, network layer, and transport layer. We saw about there might be questions like match the following regarding the roles of the layers. Okay. So in that case, we can just you have to just find out like for example network layers related to routing. Okay, so we have to take those choices. If there are two choices with network layer to related to routing, then you have to find out the best among the two that are okay. So match the following related the the functionalities of the layer. Okay, so there can be questions like this. So please go through this one. Functionalities related to the functionalities related to the layers. Okay, that can be matched the following. Okay. Yeah. Then regarding the Ethernet local area network, exponential backup mechanism. Okay. So you have to see. So this exponential backup mechanism, this comes under which topic? Collisions. It comes under which topic? Can you please tell me? Can you please tell me? Back off. It's not. It's back off, of course, but you have to please kindly go through CSMA CD, collision, Carrison's multiple access collision division, CSMA collision avoidance. Please go through this topic like CSMA/BDT, CSMA/CA. Okay, Carrison's multiple access and Carrison's collision avoidance. Okay. Okay, fine. Next, you should know about there is a question regarding bridges. Okay, about spanning tree algorithm for avoiding loops. Okay, so we should know about the different networking devices. About the different networking devices, okay, networking devices and their roles in networking devices and their roles. You should have to study about this. Okay, and especially about bridges. How the bridges are used to connect the lands, and spanning trees is used to avoid loops. Okay, bridges, okay. Bridges, routers, bridges, routers, and bridges, routers. Then we have hubs. Hubs. We have switches. Then we have hubs. We have switches. Then also we have repeaters. Why do you go for repeaters? Anybody? Why do you go for repeaters? Any idea? Why do you go for repeaters? Any idea? Okay, fine. Repeaters works in which layer? Repeaters works in which layer? Very good. Physical layer. What's the role of repeaters? So, for the purpose of amplifying the signal, we go for repeaters. Okay. Okay. Send. Okay. Then we have to study. We saw a question regarding bit stuffing. Okay, bit stuffing, the byte stuffing. You have to see. So, if there are 5 consecutive ones, a bit is stuffed, zero is stuffed. Okay. Bit stuffing. Relevant questions related to bit stuffing. Okay. Then about sequence numbers. Sequence numbers. Sequence number differ for the different protocols. The sequence numbers for different protocols. Simple protocol, then stop and wait protocol, selective repeat protocol, go back n. So sequence numbers for different protocols. Okay, for different protocols. So these protocols works in which layer? The data link layer. So, you can please go through the sequence numbers. Yeah, any idea? I think we didn't discuss this question. Any idea what's the answer for this question? For the IEEE 802.11, what is IEEE 802.11? IEEE 802.11, any idea? You can just please go through this. You can please go through this question and you can give the answer. IEEE 802.11 is wireless LAN. It is not LAN, it is wireless LAN. Can you please try to give an answer for this one? Find the answer for this question. For the IEEE 802.11 MAC protocol for wireless communication, which of the following statements are true? Anybody? Can you please give a try? Which of the statements are true? RTS, CTS, it's what? Like what? Ready to send, clear to send. Any idea? Any idea?
Sir, PPT not visible, sir.
PPT is not visible.
Oh, yes, sir.
1 minute, 1 minute. How long it's not visible?
Sir, it is
Now,
dark, sir. Oh, okay, sir.
1 minute, 1 minute, 1 minute. 1 minute. Now is it visible? Is it visible, Yogesh, right now?
Yes, sir.
Ah,
Is it
yes,
visible?
sir.
Okay, okay. Yeah. So please give the answer for the IEEE 802.11 MAC protocol for wireless communication. Which of the following statements is true or true? Any idea? Are you able to? Any idea? Any idea? So the answer is first and third one. It's like what? First one is like what? At least 3 non-overlapping channels are available for transmissions. Okay. RDS CTS mechanism. It is used for collision detection. It is not. It is false. Okay. So it is mainly for avoiding collision avoiding only we go for RTS CTS. And third one is unicast frames are acknowledged. Okay, we are having the acknowledgement. Okay. Okay, so we are seeing about that. And next, we didn't discuss this question. Next class we'll see about that. We will see about this one also. We'll see in the next class. Next we saw about IRP packet, ARP. Okay, we saw about ARP. Okay, ARP. So we have we have to know about what is regarding ARP. Okay. We discussed about ARP and the functionality of ARP, RARP. We have to know about that. So we saw that ARP is like what? We give the IP address and we get the MAC address. Okay. So regarding the functionalities of ARP, next about RARP, okay, then the functionality of the functionalities of ICMP. There is a ping command, okay, and all these functionalities we have to know about that. Okay, so this is one point which we saw. Okay, 1 minute, 1 minute. Is the PPT visible correctly now? You see,
Yes, sir, it's
it's
visible, sir.
visible now. Okay.
Sir.
Fine. So we saw that ARP protocol. So it is used for finding the MAC address that correspond to a IP address. Okay. Same like that. RARP, reverse address resolution protocol. You will find the IP address by giving the MAC address. Okay. Okay, this we saw. Then next we saw about the difference between a bridge and a router. Okay. Difference between a bridge and a router. So we saw that which of the following is not true with respect to a transfer bridge and a router. We saw that they're using like what difference between a bridge is not use a router does not use a MAC address. Okay, the router only uses a IP address. Okay, so this one point we saw, and next we saw that following about the internet protocol, the packets cannot set the route of an ongoing packets. The route is determined by the routing tables, not on the way. It is not the router is the route is not determined on the way. Okay, this we saw. Okay. Then we saw about RIP OSPF. Regarding the routing protocols. So RIP routing information protocol uses distance vector routing. Routing. And OSPF uses link state routing. Okay. OSPF uses link state routing. RIP uses distance vector routing. OSPF uses link state routing. Okay. Next, we had one question regarding to upgradation. Okay, so it's like we saw that what computational overhead in link state protocol is higher because like what the updation is also taking place in a randomly. Okay, so the differences between protocols, especially differences between link state and distance vector routing. So in link state, the updation takes place very frequently. In 30 seconds of time, it takes place like that. So it is like what the upgradation, the topology changes also is getting upgraded. It's getting updated in the routing table in link state routing protocol very rapidly. So this is the difference between link state and distance vector protocol. Okay, distance vector protocol. So these are the things you have to have an idea. Okay. Fine. Regarding the application layer protocol, tomorrow we'll discuss. Okay. Fine. So I'll share the slides also. I'll share the questions also which I have given. So if you have any doubts, you can please ask me.
Sir, I have a doubt in a previous question, internet protocol, which is an internet protocol.
What did he say?
Sir, the question is ரெண்டு question.
You have a doubt in?
Internet protocol ஒரு question அதுல கொஞ்சம் doubt இருக்கு.
This one, huh?
Yes, sir. The first option.
Can have multiple IP addresses, huh? Okay. It is possible for a computer to have multiple addresses. Yeah, I'll check and let you know, Isai.
Okay, sir. Thank you.
Yeah, even I have a doubt whether a system can have multiple IP addresses. But I think it is possible. A system can have multiple IP addresses, I think. But anyway, I will check and I'll let you know. Okay. I'll certainly get back to you. Okay. So Isai is asking a question regarding whether a system can have multiple IP addresses. Okay. So I'll check and I'll let you know. I'll let you know in the next class. If you have any other doubts, you can please ask me. Or any other feedback if you have, you can please let me know. If you have any other feedbacks also, you can please let me know. Basically, ma'am, I'm almost done, ma'am. Ma'am, I almost I've completed. If you have anything to, if you have any